Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you, YouTube. Thank you, subscribers. Thank you, viewers. It's me again, Khalid Muhammad Ariff. Today, I'm blessed to live into the 24th of Rabiul Awal 1442, 10th of November 2020. And in this video, I'm attempting to, before I say that, before we go on watching this video, please ensure that if you are, especially my Muslim colleagues, please switch off this video if you are already in a mosque waiting for the Friday prayer khutbah, or perhaps you are in some uh, uh, what they call religious events or lessons with scholars teaching and preaching. Please do not watch this video. Okay, thank you very much. Now I'm going to bring to you another activity which uh, which has safety, health, and environment concerns, and we'll discuss these safety, health, and environment and how they're linked. This activity is called surface aeration. I believe if you are a competent person in biological processes for effluent treatment, this would be related to you, and we will take a look. I will bring you there with a picture and discuss what sort of safety, health, and environmental concerns would be of our particular attention when we are operating the so-called aerobic treatment, surface aeration of an effluent, organic effluent treatment from one of the agricultural industry in Malaysia. Now, this is one of my favorite old picture of the aeration pond for a biological treatment of an industrial effluent coming from the palm oil mill. So this is the palm oil mill effluent in Malaysia is known as pomeh. Okay, now this is one of the ponds. I believe this is towards the later one of the final ponds in the treatment of a palm oil mill effluent, because initially they have got to remove all the fats and oil. Okay, you have got the removal of all these fats, and they go into an anaerobic ponding system, and then facultative, and then aerobic treatment, whereby by the end of this treatment you've got a clarifier pond, another kind of with an aid of a surface aerator to ensure enough dissolved oxygen is in the water and for treatment. And this is my favorite, because you could see the color of this. This is what I associate with the uh, color of a teh tarik in Malaysia, and this is a very healthy culture of bacterial cells in its endogenous phase. And when we took sample from this pond, we have found about 4,200 milligram per liter of MLVSS, mixed liquor volatile suspended solids, which is marvelous population of bacterial aerobic bacteria for the decomposition of all the organics from the effluent. So this effluent is organic because it is from palm oil mill, and nutritious, lots of nitrates, yeah, and also phosphates. And okay, and this process is using surface aerator. As you could see, there are about 6 surface aerators. All right, these are all mechanical aerators, which is actually circulating, and they are powered by electrical energy. So you got wire submerged down there to turn the blades for the or the propeller of the aerator. This is a surface aeration technique, one of the treatment ponds found in the treatment of effluent discharges from palm oil mill operation, probably from autoclave, from hydrocyclone and all this. So all this water will be the so-called wastewater. Now let us discuss. Look at this point. Safety first, right? So safety in terms of potential hazards. What do you think? This bun, the one you find here, is a hazard itself, because there are a number of times which I have visited and audited some of these mills before we found that the bun broke, the bun gave way, and water, really untreated effluent, this is wastewater effluent, are being overflowed out of the system and gets into the nearby ditch, and that is one potential hazard. And also electrical circuits is a potential hazard here. As you know, the wiring, the power is applied to this place. It's all cables, wire, all sorts of wiring, all right, and it is supposed to power to ensure that the surface aerator blades are working. And the blades itself, the mechanical system of the aerator, is itself a potential hazard. Okay, and of course the effluent pond, the entire effluent pond, is a potential hazard. So what would be the associated potential risk? Somebody fell into the pond. I almost entirely fall into this pond. I got I got one of my left foot, into the pond as I was attempting to collect water sample from this pond. Because we want to do input-output analysis of the quality of before treatment, during treatment, and after treatment of water from this pond. So in one of my attempts to take the water, the bun is soil, and it is soaked with water, saturated with water. So when I stepped in with my excessive kilos, the bun actually sink in. I got half of my foot, left foot, in literally, really, in almost into the pond, and I got wet. Yeah, of course, that's one. And in many occasions, we have animals like cattle. We have got what they call wild boar that has got themselves submerged in the pond, and they've got to be rescued. And those are potential risks associated to the pond itself. And of course, people get injured. I twisted my ankle, but I'm okay now. And also we have got, as I mentioned, it is some of the risk could be a wildlife intrusion. And there was one time, I think because this area is cool, there was one time I was walking around the pond, checking the conditions of the bun, but those grasses were high. And I stepped on something which is like smooth and soft. And when I look down, I saw some pattern, a coil, large. I looked down as something struck my mind, and I look at the pattern. I know it is a phyton or constrictor, you call it. I called a few people. I said, there is a snake, run. And you know what? That was the first time in my life that my running I was able to overtook a few of my other guys. And if it was a 100-meter dash, I believe I would have made it into a qualifying time, at least for Malaysian Sukma. I was a rugby player, but I don't run that fast. But this time, because of that incident of some wildlife intrusion, I stepped on a snake. It's a python, huge. It's like as big as my thigh, and it was coiled, hidden by the grass. It was one time. And after that, I told the mill manager, you got to ensure the grass are all cut every fortnight to ensure it is short enough for us to be able to see any wildlife or endangered species, because we respect all this wildlife. They are supposed to be there. We are at fault because we intrude their place. We build ourselves aeration pond to cater for our mill discharges. Well, that is potential risk. So, in terms of safety, that is how it affects the risk. And well, when we fall and get injured, and it would cause an impact to the environment, because we need to have some medical attention. We might spill something on the way, and that would cause environmental impact as well. So that would be a problem. And for the organic effluent itself, it is water. There is it would cause some problem to safety, because water in a pond is a potential hazard, as been discussed. And when we go the other way around, this organic effluent, the organic influent, the untreated, sorry, partially treated effluent discharges from the mill is affecting health in ways that you can think of. Industrial hygienists, as I said, I'm not an expert in safety and health. Industrial hygienists, safety health officers, you are better off than I am in discussing safety and health. But as far as the influent is concerned, it is containing high chemical oxygen demand and high biological oxygen demand, and very high content of suspended solids, where we have all the minute microbes invisible to the naked eye, which can be pathogenic, which can cause transmission, which can cause diseases or transmission or waterborne transmission of diseases. On top of that, you may have worm spores or some bacteria in cast form, hibernated, and some of the pathogens or disease causing microbes can be a potential to human health if they handle this effluent without proper PPE. And our friend might get sick because of that. And when he is sick and working, as you know, some of these bacteria has got what they call endotoxins, or perhaps some form of microbial toxins, which can cause immediate disruption of the nerve system. And our friend, due to that sort of intoxication or contamination or infection, might not be able to work in a proper, sensible manner, and would cause a potential hazard, which would lead to some form of accident and cause some impact to the environment for not able to follow the safety procedure in the operation of this particular treatment plant. Okay, I believe you can do better than that, better than what I did, and this is my attempt to link the concerns of safety, health, and environment, and I believe you are able to do better than that, expand more into that area. I am only trying to help integrated management system of safety, health, and environment, or HSC or ESH, or whatever you want to put it. But for me, safety is always first, so she is always right. Okay, and my concern, my line of field of not to say expertise, experience is more into the area of environmental management. So let us take a look to important what you call elements in environmental management system. Especially, I'm trying to adapt here what is employed by ISO 14001 version 2015 pertaining to environmental aspects from its life cycle perspective, and to look into risk and opportunities related to this surface aeration. So if you are in the palm oil mill and you have ISO 14001 version 2015, I hope this video would help you. Sorry, my studio LED light just went off. I've got spare now on, so never mind. So let's assume now I am the environmental management representative working for this palm oil mill, and I'm assigned to identify all the environmental aspects related to the operation of a surface aerator for this particular what they call biological effluent ponding system, a treatment method. Now, of course, there would be an array of environmental aspects involved in the operation of these particular aeration pond or a surface aeration treatment technique. Of course, all the inputs are mechanical aerators, the bun itself, the influent or the effluent that coming in into this pond, all the equipments, all the auxiliary, apparatus, electrical wiring, electrical motor, etc., etc. These are all the main environmental aspects. Now, I'll be choosing only one of the output aspect first. Now, what comes into this pond is a partially treated biological organic effluent, high in organic content because it comes from the palm oil mill effluent, and the BOD is easily in the region of say 400 to about 800 milligram per liter, COD maybe 1,000, after passing through the first few ponds before this. And maybe you have got about BOD in the region of, as I said, 400. COD could be 800 to 1,000 depending on the content of lipids especially. And suspended solids is also quite high in that region as well, about 700 to 800 milligram per liter, and we've got to bring it down to standards. And normally for palm oil mill, for ponding system, they would achieve after treatment discharging effluent quality around 50 to 100 milligram per liter of BOD. BOD is biological oxygen demand, and also the COD might be around 200, 250 milligram per liter of COD. Suspended solids around the region of 100 to about 300 milligram per liter. It's just by experience. Now, our concern is this environmental aspect, which is the input effluent into this particular pond, which is a surface aeration pond. It's a biological treatment technique, and this pond is not deep because it is an aeration pond. If it is slightly deeper, then we got to use mechanical aid like all these mechanical aeration technique to ensure good exchange or good intake of air into the water body to enhance the content of dissolved oxygen, to enhance the microbial growth of aerobic bacteria, which would decompose or use up all the organics in the water and bring them and convert them into carbon dioxide and water. And aeration tank, you are going to end up with a lot of sludge. All right. So let's concentrate on the treated effluent. The output. Treated effluent is an environmental aspect, but it goes out of this system as an output aspect. Now, what is the associated environmental impact to this output aspect? The treated effluent will interact and can interact to any water body that receives it after it has been discharged out of this pond. It will flow into a water body. You've got organisms, you've got other things, other ecological inhabitant of the water body, and there will be interaction. And please remember, although it is a treated effluent, it still carry with it residual organic content because the BOD is still there. 50 to 100 milligram per liter is the BOD. On top of that, the flow rate that comes out can be in the region of 20 to even 100 meter cube per hour. There's a lot of water coming out and entering the nearby waterway. It could be a ditch, it could be a small stream, it could be a river. And that would be causing, with the BOD and the flow rate, you get a biological load or organic load. Concentration multiplied by flow rate, you get high organic load, not due to the concentration of BOD in the region of 100 to perhaps 100 to 150 milligram per liter, but when you have 20 to 70 to 100 meter cube per hour, can you imagine the load? That will eventually, despite the fact that they are able to meet the regulation or the permits of their discharges, they are still causing water pollution because of the load. Therefore, pollution is not because of concentration alone. Pollution is not because of flow rate alone. Pollution is due to pollution load. And pollution load is a function of concentration and flow rate. Concentration multiplied by flow rate, you get mass over time. Mass per unit time. That is the factor that causes pollution. And it brings along with it solids. And what happened? Some of these solids are actually dead microbial cells. Some of them are microbes, viable cells, living cells of microbes. And they have aeration, nitrification and denitrification occurring as well, despite that the fact that they have left this particular pond. And the solid buildup eventually will cause another problem to the environment and impact called sedimentation, shallowing of rivers. I can't imagine if there's a heavy rainfall, a lot of surface runoff from this almost bald, it's just a minute vegetation, would flow into the river. Well, never mind that. On top of that, look, the water is being channeled out and flow into a nearby river or ditch. And the nearby river is in existence naturally with a certain level of equilibrium. They have a certain point of stoichiometry in the chemical and biological and physical factors already existing in the river water body. There is a balance of aquatic life and aquatic fruit, the phytoplanktons perhaps, and they've got enough nutrients from naturally occurring contributors of nutrients in the river, natural by itself as it is. But with the introduction of this palm oil mill and also all this vast, huge biological treatment plant in terms of ponding technique, and due to the large volume of effluent discharges from all this palm oil, even though it gets treated and passing the permit restrictions, passing the discharge standards, the volume of water is now an additional load to the existing waterways. So those rivers are actually receiving more water. In other words, their hydro cycle is being tempered. There is an intrusion of new volume of water into their existing stoichiometric hydrological cycle, natural hydrological cycle. This water add in into the equation, and of course this large volume of water, talking about 20 to 100, maybe over 100 meter cube per hour as new water input into an existing natural waterway, what would happen? The water cycle gets imbalanced. Okay, and that is another environmental impact to me, not just water pollution. We are causing a disruption of the ecological balance of a naturally occurring river, and a river which has got its cycles, the equations of all the biotic and abiotic factors in their equations balanced out. But with the intrusion of these discharges, the equation will get imbalanced. High nutrients level in this water, remember there's still BOD, would cause perhaps some form of eutrophication, excess nutrients in that river, and you've got worms, you've got all sorts of additional load of microorganisms into the river that would of course be a luxury to some species of organism, and there is an excess of certain organism, and that would also disrupt the food chain of the receiving water body, of course, at lower trophic levels, not at high trophic levels, and it's not quite evident to the human eye. We still see water only flowing, but the evidence is downstream from these discharges. One can find, in fact today you can look at some journals, there are reduction in um, aquatic life of the river, and there are reduction in popular delicacy of the people living around the river. The water gets dirty, smell, and all this. and you're welcome to read those journals, okay? And this is causing water pollution. Okay, let's get upstream. Let's get upstream of this effluent and take a look at the influent, what comes into the pond, which is an organic influent. We can call it influent, but from where I am from, we still call it raw effluent or semi-treated effluent. And our concern in environmental management is to ensure that we know whether this is an output or input aspect. So for this, remember, for this particular activity, which is surface aeration, the organic influent that enters the system is an input aspect. So what sort of environmental impact would it cause? So we got to look at the upstream of its life cycle perspective. And the upstream means we got to check where this organic influent comes from. It comes from the palm oil mill. Where does the water come from? From the processes in the palm oil mill, hydrocyclone, autoclaves, and now they've got new equipment, and all comes from palm oil fruit. Where does it come from? Agriculture crop of palm oil. What is the environmental impact? Palm tree is replantable after it has expired or towards the end of the life cycle of a palm tree, say 12 to 15 years, the fruit production is much less, or the extraction rate from the fruit is much less, though we cut the trees and replant. That, in that sense, it is renewed resources. So it is a form of resource conservation as far as the environmental impact is concerned. This is a plus point. Therefore, agriculture is on a renewed resources. We do not deplete resources, but we need to have a good agricultural management, especially in sustaining the fertility of the soil that we grow all these plants. And of course, upstream, when we want to develop an agricultural land, it involves the cut down of forests and converts green tropical forests into palm oil plantation that has an associated environmental impact, which is deforestation. Nonetheless, the economic, when we do environmental management, especially when we do environmental accounting, or if you are an EIA consultant, you know this, cost and benefit. The cost in having palm oil agriculture is forest. The cost is deforestation. But in terms of environmental, socio-economic, it is a renewed resources. We can replant these trees, and in socio-economy, we are generating work, labor, we are creating jobs, and in the economic and sustainability of human lives, it is producing all sorts of products essential to human, from the cooking oil right up to oleochemical products such as soaps and many other applications. So we have got to look into the cost and benefits. Eventually, we are able to maintain at least green, but beware, we have got to study the soil. For excess fertilizer always is an issue in plantations, not just palm oil plantations, any other plantations as well. Excess fertilizer is bad for the environment. It causes a lot of ecological imbalance and has caused namely eutrophication, but there are other eventual or subsequent environmental impact from eutrophication, and it involves the food chain. Okay, so that would be the organic influence. Output aspects. Impact is good impact is resource conservation, but on top of that is eutrophication and perhaps excess soil deconditioning. Okay, you can say that as an environmental impact. Now let's take a look at another environmental input into this activity, which is a very common material that has been, has got to be serviced from time to time on top of, you know, the system. Uh, we'll take only one, the aerator shaft. You got this surface aerator is working with a shaft, and I'm just taking one example. There are many other things. It's the ball bearing, it's the gears, it's the, what do you call it, the motor, it's all involved. And all these do get kaput and has got to be repaired and changed with new parts. The aerator shaft, if it is broken, we have got to bring in new shaft. That will be an input aspect into this activity. And what is its environmental impact? Of course, since it is an input aspect, we got to look upstream of the life cycle perspective. Where does it come from? The shaft is made from metal, and metals come from metal fabricator, comes from the smelting of metal ingots. Where does it come from? Iron ore, perhaps. Where does it come from? From mining. So all this leads to the mining of natural resources, and of course, popularly, you know this well, the more demand for metal means the environmental impact is resource depletion. The metal in the mesosphere of the earth gets less, and on top of that, the mining has caused a substantial geological damage because we got to blast hills, we got to excavate, we got to bore, we even have encavement, underground caves to explore and exploit and extract natural resources embedded in the earth structure, okay, beneath the surface of the soil. In simple terms, got it? So the more aerator shaft kaput, the more demand for natural resources, thus causing an environmental impact, resource depletion. Okay, so what would be the associated risk to this activity? Okay, remember environmental management definition, ISO 14001. What are we supposed to do? We are supposed to manage environmental aspects by fulfilling compliance obligation and by addressing risk and opportunity. So we have identified the environmental aspects, and how we manage it is by managing this aeration to ensure, by managing the release of the treated effluent, managing the organic influent, managing the mechanics of the surface aerator, and overall managing the entire palm oil mill factory. What? Managing all the environmental aspects so that they would not cause or eliminate or reduce the risk of environmental impact associated to them respectively. That is environmental management system. Therefore, we have to identify, we have to know and address associated risks, in this case related to this particular surface aeration. And what is involved, importantly, is we are exposed to legal liability. There is a law governing not only the final discharge's quality that is being discharged from the spawn, we got to ensure we operate all the ponding system based on the approved plan, approved drawing, design, and criteria by the respective DOE agencies. And failure to do that would bring in legal liability. On top of that, there is the discharge standard that we have got to comply. We got to ensure that this particular surface aeration would be able to really bring down the BOD level to stipulated limits prior discharge, prior releasing it out of the system. That's a legal liability. And when they talk about risk, the bonding can break, the bonding can, fall, and that is another legal liability over there. And there's a risk associated to it, and also to the sludge that we get from this aeration. So it all depends on the permits. The palm oil mill in this country, Malaysia, where I'm from, is a licensed premise, is a prescribed premise under the Environmental Quality Act, under the Environmental Quality Palm Oil Mill Operations. I think the regulations 1976, 77. Correct me if I'm wrong. So there is associated what they call legal responsibility. And another risk is aeration failure. And when aeration fail, I think you understand what would happen. There is not enough dissolved oxygen in the effluent, thereby affecting the aeration, the aerobic breakdown of organics by aerobic bacteria. And when there is less dissolved oxygen, what would happen? A anoxic condition would develop, aeration, aerobic bacteria will be less in population. It will be taken over by perhaps facultative bacteria, and the process of denitrification will overwhelm nitrification, therefore releasing more nitrogen, and which is actually good, but eventually anoxic condition will develop into anaerobic conditions and would cause smell like hydrogen sulfide and other pungent smelly stuff. And of course the BOD level might shoot up because the organic content will be higher due to the failure of aeration process. Okay, and another risk is the fact that this particular pond is an open pond. It is susceptible to heavy rain overflow. Heavy rain doesn't worry me, but what worries me now, one of the effects of acute climate change, acute weather systems occurring in the world, many parts of the world, including this country, there are situations when heavy rain occur for a prolonged time that causes the topsoil to be saturated, and before any worse thing could happen, that outfall or perhaps surface runoff from the higher elevated areas that flows through this area might flood this pond and cause an overflow. That is another potential risk. Has it happened? Many times before, especially in the last 10 years. Is it a problem? Yes. All this nutrients from this pond and also pollutants in the form of scum, and also the agitation would cause some of the sludge to surface out due to the displacement effect of surface runoff. Then it will flow out of the system and contaminate and intrude the adjacent water bodies or the rivers and causes a, an impact, water pollution to the nearby rivers. That would happen as well. Okay, would there be opportunity to this? Yes, I have a few, and most of it has been done here in this country. What we do is we reuse this water. The treated water is not really discharged out into rivers, but we use it for irrigation or even to water some crops. And in some instances, we have reused water for use for recycling and reused in the mill itself, because as you know, palm oil mill is a self-generation plant in terms of energy, and the boiler generates steam enough to turn turbine, and they power their own plant with their own electrical energy from the combustion of empty fruit bunch kernels fibers, which they burn in the boiler and produce steam for that, enough power for the whole plant. And on top of that, we might, yeah, that would be amounting to recycling of the water and recycling of all these materials that you can see over here, especially the metal aerator shaft. These can be recycled. And on top of that as well, we would be also looking into crop irrigation or fertilizer scheme, especially when we talk about sludges coming from the cooling pond and also from the aerobic pond. Sludges can be reconditioned and be used as what they call fertilizer. And also in many instances there are many of these sludges that has been converted into biogas. And in fact, one of the company in Malaysia won the first Asian Energy Award way back in the year 2000. If not mistaken, it was in Manila, Philippines. Malaysian company won Asian Energy Award because they have converted all the sludges, sent them to an anaerobic digester. They were able to get the calorie per kilogram of sludge enough for them to be converted into biogas. And the biogas that they produce were used by their quarter houses. Nice. And in fact, other mills in this country should follow the same steps, but there are some protocols, bureaucratic thing that hamper engineers and local scientists to pursue. But this is life. We are managing not only the environment, but we have got to manage the environment in favor of the system somehow. So this is the best I could do. I'm sorry it took us too long for this particular slide. I hope you're able to capture, understand the link between safety, health, and environment as far as surface aeration of this biological system is concerned, and also taken a look at the environmental aspects and their associated probable impact, risk, and opportunities associated to this particular activity and its related environmental aspects. Thank you very much for your attention. Thank you very much for your time. Thank you, YouTube. I wish everybody in Bahasa Melayu, semoga dikurniakan kesenangan, keselamatan, kesejahteraan, kebahagiaan dan kejayaan kehidupan di dunia dan di akhirat. I wish everyone, until we meet in the next video, inshallah. Assalamualaikum warahmatullahi wabarakatuh.